Hey guys, welcome back to the channel. I have another ECM test. This is for Frank Wave in Canada. He sent this computer. It's a 4.3 Merc Cruiser. It's a no star, no communication, and it is happening in here. I have already a few pictures. I got the computer even open because trying to do tests. Yeah, this is his computer cover, a little corroded and rusted. You can see outside, but this is his computer. So let me try to establish communication. So, it's on. You can see, and it's drawing some amperage. And I'm going to show you why it's doing that, which is like it's almost everything is for the computer to talk and work, but there is no communication. And it's because the microprocessor is not working. So let me just stay here for a second. Like that, you will see that there is no communication. And this one usually connects really quickly. I have another ECM. That one is a 7.4, but it's a Mercruiser MEFI 3, so it's the same communication as at least. Um, I have also here ready for the video. What did I do with that right here? I should probably let me actually close this and let me go over to the folder 1 second because I got all the repairs and as you see, I got a lot of information for these computers. And I have also, all this is my own information as you see here. What I want you to, or what we're going to do is first check voltage rails. Very important to make sure that we can, or we have what this microprocessor right here needs to work. So we will have the power is entering on this computer here. Then we have, this is a power transistor to protect the computer, right? Kind of like a diode, let's say, right? We got the 5-volt regulator, we got some diodes, I'm sorry, some capacitors in here, more, and then this is another IC that controls part of the communication to the EEPROM, and this is a crystal for that. We have a voltage regulator here as well, and this is communication coming from like the serial. That's how the computer talks to the diagnostics. And some other stuff in here that is not really important, but so let's check the voltage rail. So let's first check for these 12 volts. We need to see this power regulator, change it from 12 volts of battery voltage. Let's say, when I did this test, I was checking like 12.5. This one is actually a little higher than 13.5 because I changed my power supply internally on it, and now it's a little better. But the A volts should be there. So I'm using my new multimeter. I got one for the shop and one for here because I love this 289. It's just such a great tool. It's amazing. I love it. It's expensive, but it's really good. So let's check for the 12 volts. So let me put my glasses 1 second. All right, so I'm going to try to keep you here while I'm doing the check. So we should see around battery voltage in this is a capacitor entering, and we have 13.4. So battery voltage is good. We should have a battery voltage in here, and we should have 8 volts here, and we do, and then for this to work, it has to have a lower voltage. So this is how it gets active. So if you have battery voltage on one side, and then the way it works is activated by a lower voltage 12.4. So but that is there. We are going to check this other cap in here, and this one is 8 point something, 8.18. If we go there, we can see that all the voltages are matching. The next one, this one should be at 2.2 volts. Let me get this a little closer. Perfect, no glare in there. So this is a 2.2 and close. This should be a 5 volts, and it is. This should be 12 volts or battery voltage. And this power IC should have battery voltage, and it does. So all the voltage rails are working good. It should be 5 volts, and we do have that there. All right, so going closer to the microprocessor because this is at the end what I want to show. So we should have a ground pad in this microprocessor here. So this should be around 0 volts, and it is there. And then the next one should be a 5-volt reference, and it's there. So the micro has everything that needs to work. We should have another voltage rail here. This should be a 5.2 volts in here. So we are pretty close to what is needed. So everything around this microprocessor is there. Voltage regulator, 5-volt reference. The 5-volt regulator is good. This is the crystal oscillator for the microprocessor. The microprocessor sends a voltage, or sends, sorry, a voltage, and then the oscillator, or the crystal oscillator, start to oscillate, and then that creates the clock for everything to work, the EEPROM and all the stuff. And this should be having 2.4 volts in here, and we got nothing. And the problem is that voltage comes from the microprocessor, not the other way around. How I know that? Let me also show you another picture, because well, we can see that in here. So we can see when the crystal is oscillating. So we have the 2.4, which is steady through this resistor, and then the signals comes inside here, and then a 2.1. So there will be a difference. And this is measuring with the multimeter. If I put the oscilloscope, which I have also those captures, we will see that. But let me just show you, because I removed some of the cover on the microprocessor, where we're able to see, or we will be able to see how the lines, and you can almost see it in here, how this goes here and then enters in here, and then the other line comes in here for the other side. So both are interconnected to the microprocessor, and it's that it tries to, like if I excite it with the um, multimeter, which, remember, when you connect the multimeter online on series with anything, you actually send in a voltage, a small voltage, 3 to 4 volts, depends on your multimeter, and that actually excites the crystal momentarily, and then kind of like makes the computer work, but just for a brief second, because it stops as soon as it's no oscillating. Because if I will provide a voltage, and sometimes it does it, sometimes it does not. Like this, not it's not happening. Maybe if I put them in resistors, let me see, because sometimes depends on what you're trying. No, and it is on. Yeah, computer is on, and it's no communication. But yeah, so what I wanted to show, well, let me show you how the crystal should look. So give me 1 second. I save the image so you guys can see it. So I want to show you that the part number, or what is the stamp on there, is the D3278B or 788. It's a 32 kilohertz oscillator. Let me see if this camera will focus into that, because sometimes it's a little, and it's not the camera, it's actually um, the phone app that I'm using to record. This one is a D32780, right? Yeah, so, and this is the same, it depends, like this is a 7 D327J9. Oops, sorry, and that is the same oscillator, different printout numbers on the top, but that's the voltage signature. So we'll go from, as we can see here, from 751 millivolts to 2.7, and this is, let me see, closest to the micro on the tantalum side. Let me just see, tantalum side. So this will be on this side. So that's the, let's say, the 2.4 volt. And then the other one, we can see the rides in between 799 millivolts to 4.1 volts, so 3.3. And this is with an oscilloscope with a attenuator, because if you try to touch this with anything else, that will just reset the computer. And that's the opposite side, as I name it in there, MEFI 3, crystal value spin closest to micro, opposite side of the cap. And that's how it looks. Again, it's a 32 kilohertz signal, and we can see this frequency right in the bottom. So you see that what I'm telling you is 32.7, almost 33 kilohertz crystal oscillator, and that is from a known good. All right, so what I'm going to do is I'm going to remove his computer, and I'm going to show you that what I am indeed telling you is truth, and is what applies to here also. Another thing that I wanted to show is the communication, and this is nice because let me clean the multimedia. All right, connected now my computer. This is again a 7.2000 Merc 350 Mac. Um, calibration is E930, and we will see that in a second. So let me power up. You will see right here, this light is for the fuel pump relay. So as soon as you power these computers, you should have fuel prime, and you should have the IAC valve active. If I now try to establish communication, let me put this rack here, which before we didn't have. As soon as I connect, you will see that this is really quickly. It detects a computer really fast, and then you select mode 1, and then a standard diagnostic mode, and then boom, we're right there, and we can see the calibration E930 with 660 hours. So this computer is live and good. I was going to say I'm not really happy. I just got this multimeter. I don't know if you can see it on the video, but it is full of dust inside. Not really impressed with the quality on this one as far as um, having all these dots inside. How is you going to have a multimeter that has all these particles already brand new? I don't know if you can see that in the video, but those are not outside. They're inside. Hopefully you can see that I'm trying to clean that, and it's kind of like another screen on top of the screen, but that should not be there. Not on a very expensive like this. But let's focus into the repair, right? All right, so things that I wanted to share or show, and I forgot to show that in the other one because I was putting my glasses, I think. But communication, and this is nice about these multimeters when they're that fast. Like these will have the serial communication coming in here, and I want you to see that bar at the bottom. You see how it's kind of like flickering? That is communication. If I go over the other computer, and I forgot to show that, it's 35 volts. This is flickering because it's establishing communication. So this is averaging, trying to do an average of a range, but it's telling you this, in between 3 to 5 volts, and you can see how it's flickering. So that's another way that you can understand or see if you have communication on a line, right? But yeah, going into, I mean, this computer is talking, so I don't need to check the voltage levels or anything else. What I want you to see is in here, we got a 2.5 volts that I was to refer. And then if I touch, and I want you to see this light in here, if I touch in here, this other side, you see it's reading 2.1 volts, but I want you to see what happened when I release it. You see, I reset the computer. As soon as I got that multimeter in there, it kind of like, you see, oh, I gotta plug my computer, so give me 1 second. Yeah, I was about to die, 7%. But yeah, when I do that, what I did is I just reset the clock because obviously that is it has a high impedance on this multimeter, and that is not. That's why you need to use an oscilloscope with an attenuated lead, so you don't reset. Let's say how you said that, like, well, you don't reset lines or signals like this one because I'm tired and my brain is not thinking too well on the words. But yeah, so with this is good enough of a test, and also to prove to or share this with Frank that is nothing I can do with this computer. The problem is inside the microprocessor. All the voltage rails around are there. Everything is working as it's supposed to. The microprocessor is not sending the signal, and that is nothing I can do. All right, guys, I hope that you like the content and you see how much information I'm sharing. I'm not, hiding everything, all information. A lot of people is like, oh, why you don't show the part numbers and tell me where to get it? I'm like, I'm not trying to make a competition for myself. I share information, but I'm not going to share like where to get the parts or what the part numbers are. I mean, this is a business. I am trying to help technicians and other people that is trying to learn some electric, knowledge or electronics repairs, but I'm not trying to make a competition kill me. All right. Hopefully that is understandable and reasonable. All right, guys. Thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.